Chapter 5, Section 9, we're going to finish off the chapter looking at fractional equations. We are also finishing off Algebra 2 Standard 7 and going a little further with Standard 15, solving rational expressions to see when they're always true, sometimes true, never true. What is a fractional equation? It's an equation in which a variable occurs in the denominator. Solve them. First, factor all the denominators completely. Second, determine what the domain is. What I call find the restrictions. We want to find the values of the variables that would make the denominator 0. We have to restrict these or exclude them from our solution set. Then we find the LCD. Next, we multiply the entire equation by the LCD. We have to be careful though, because sometimes this will give us what's called extraneous roots, which is big vocab for an extra answers. So we solve our equation, and then we could have an extra answer, so we need to check our answer to make sure, first of all, that we don't have any extraneous roots and that our answers are not the same as our restrictions. That is a long game plan. Let's look at it by example and see what can happen. X minus 1 over x minus 7 equals 6 over x minus 7. First thing is we cannot allow 7 to be part of our domain. X cannot be 7. 7 minus 7 is 0, which we can't allow 0 in the denominator. Next, our LCD is x minus 7. So if we multiply the entire equation by x minus 7, those cancel out and leave me with x minus 1. These cancel out, leave me with 6. And when we solve this, we find out that x equals 7. But wait a minute. My answer is my restriction. I can't not allow 7 to be my answer because that would give me 0 in the denominator. And if that is the case, my only answer is my restriction. That means this can never be true. There is no solution, which we can write the words no solution or the null set symbol there. So no solution, never true. No value of x can make that true. Let's look at our next example, which looks deceptively simple to start. X over 1 plus 6 over x equals 5. We don't have a problem with this x because that's x over 1. This x, we cannot allow x to be 0 because that would give us 0 in the denominator. And since my only denominator is x, that's my LCD. Let's multiply everything in the equation by the LCD before we do. I have x to the first power, so I'm expecting one answer. Let's see what happens after we multiply by the LCD. So x times x is x squared. The x is cross-reduced, which leaves me with 6, and that is equal to 5x. And now what it looks like when I get everything on one side and nothing on the other side, fundamental theorem of algebra, I look at the x squared, and the fundamental theorem of algebra tells me I'm now expecting 2 answers. We started out expecting 1, multiplied by the LCD, now we're expecting 2 answers. Possibility of an extraneous root. So what we have here is we started out with linear, ended up with quadratic. We must check our answers. All right, let's factor this by trial and error, by FOIL backwards, I'm sorry. And that factors to x minus 2 times x minus 3. Zero product property says set each factor equal to 0 and solve. So x equals 2, x equals 3. I check my answers against my restrictions. No problem with that. But before I think that those are my solutions, I must check my answer on today's lesson to see if it really works out or not. So we start with the original equation. Everywhere we see an x, let's replace it with 2 and see if we get a true statement. 2 plus 3 is equal to 5. Well, that works. 5 is equal to 5. Let's check our answer for 3. Everywhere we saw an x, replace it with 3. 3 plus 2 is equal to 5, and that works out. So we did get an extra answer, and in this case it turns out to be a bonus answer, not a bogus answer. So my solutions, plural, are x equals 2 or x equals 3. We started out looking for one answer, we ended up with 2, we got an extra answer, In this case, both of them worked. It's possible that one of them could work while the other one doesn't. It's also possible that neither one can work. So let's continue on with another example. This is 2 over 1. So we have three fractions here. Let's factor x squared minus 7x plus 10 by FOIL backwards into x minus 2 times x minus 5. This will not factor, so let's treat them as factors. And find my restrictions. X can't be 2. 2 minus 2 would be 0. X can't be 5. 5 minus 5 would be 0. And x can't be 5. Again, 5 minus 5 is 0. There's my restrictions to my domain. LCD, x minus 2 shows up, I'm going to take it. X minus 5 shows up, we're going to take it. That's my LCD. Let's multiply everything in the equation by the LCD. In the first fractions cases, the x minus 2, x minus 5's cancel out, leave me with 3. Second fraction, nothing cancels out, so I've got 2 times x minus 2 times x minus 5. And the other side of my equation, the x minus 5's divide out to 1, and I'm left with x minus 4 times x minus 2. Simplify that, FOIL these out, gives me x squared minus 5x minus 2x is minus 7x plus 10. This is x squared minus 2x minus 4x is negative 6x plus 8. Let's distribute out the 2 to get 2x squared minus 14x plus 20. And we need to try to get everything on one side, nothing on the other side. When we do that, I'm going to subtract x squared from both sides. 2x squared minus x squared is x squared. I'm going to add 6x. Negative 14x plus 6x is negative 8x. I'm going to take the 23 and subtract 8 from it, and that gives me 15. Factor that by FOIL backwards is x minus 3 times x minus 5 equals 0. Zero product property says set each one equal to 0 and solve, which I did in my head since they're so easy. X equals 3 or x equals 5. I check my answers against my restrictions. Remember, x could not be 2, x could not be 5. So x cannot be 5 means I have to throw out my answer of x equals 5. And I've got x equals 3, but we don't know for sure until we check our answer. So let me start with the original equation. Everywhere I see an x, replace it with 3. So that's 3 over 3 squared minus 7 times 3 plus 10 plus 2 equals 3 minus 4 over 3 minus 5. Simplify that and see if we get a true statement or not. So 3 over 9 minus 21 plus 10 plus 2 equals negative 1 over negative 2. Let's continue to simplify. 9 minus 21 plus 10 is negative 2. And negative divided by negative is positive. Continuing, that's negative 1.5 plus 2 should equal positive 1/2. 1/2 does equal 1/2. So x equals 3 is my answer. It does check out. So I check my answers against my restrictions. I check my answer in my problem. And it does work. Alright, let's look at a real-life situation expressed in sentences. Looks like we've got a distance equals rate times time situation. So when in doubt, chart it out. An airplane flies 1,062 kilometers with the wind, and the same amount of time it can fly 738 kilometers against the wind. The speed the plane can fly in still air is 200 kilometers per hour. Find the speed of the wind. So we've got our plane going with the wind and against the wind with distance equals rate times time. Filling in the chart, distance with the wind is 1,062. Distance against the wind is 738. The rate, now think about this carefully. The wind is going to push the plane along when the wind is at the back of the plane. So that's 200 plus the rate of the plane. Against the wind, it's 200 minus. Now be careful. If you wrote r minus 200, then that is implying that the wind is faster than the plane, and you can get in trouble if the wind is faster than the plane. You can't fly backwards. Time, well, we don't know much about time with the wind. Let's call that t. And time against the wind, we know that it's the same. So we know here that in the same amount of time. So both of those are going to be t. Let's get t to be the same since the times are the same. Let's take distance equals rate times time and turn it around a little bit so we know that time is distance divided by rate. So with the wind, that's 1,062 divided by 200 plus r. Against the wind, that's 738 divided by 200 minus r. Since the times are the same, we can set 1,062 over 200 plus r equal to 738 over 200 minus r. Solve the equation. Well, first we need to watch out for our restrictions. If the wind is negative 200 miles an hour, or the rate of the plane, we're in trouble. And if the rate of the plane is only 200, we're also in trouble there. The LCD is the 200 plus r times the 200 minus r. So we're going to multiply the entire equation by that. The 200 plus r cancels out, leaving me with the 200 minus r times 1,062. And on the right side, the 200 minus r's divide out, leaving me with the 738 distributed to 200 plus r. Let's do the distributing. So that's 212,400 minus 1,062r equals 147,600 plus 738 minus r. If we get all the constants together by subtracting 147,600 from both sides, we get 64,800. If we get all the r's together by adding 1,062 r's to both sides, that gives us 1,800 r. And dividing by 1,800, we find out that r is 36 kilometers per hour. Did we answer the word problem's question? Well, the question is find the speed of the wind, which we're using r to represent the rate of the wind. We solve for r, so the rate is 36 kilometers per hour. That's not my restriction 200, so we're doing okay.